So, welcome back. We have looked at epistemic logic, we have looked at the language, we have looked at the kind of sentences that you can express in that language, and we have seen that how the semantics can be modeled using Kripke structures or the possible world semantics, in which there are many possible worlds as shown in the diagram that we were just looking at last, when there are 3 cards and 3 people who have picked up the 3 cards. And we have edges between possible worlds, saying that, for example, agent B cannot distinguish between the world 0 to 1 and 1 to 0. Now, of course, agent B, which is Bob, is holding the card 2, but he does not know which of the other 2 is holding 0 and which of the other 2 is holding 1. So, it cannot distinguish between these 2 worlds, in which one Anne is holding 0 and in which Anne is holding 1 essentially. And we saw that there is always the real world that we often use for reasoning. So, often the task is to find out what is really true in the world when you have incomplete knowledge. So, you can make some inferences. So, like in the puzzles that we saw earlier. So, let us talk about actions. How do you get to know more information? So, actions can be of 2 kinds. One is called ontic actions. These are actions that change some propositions in the set of propositions. So, for example, a robotic agent may pick up a block, thereby deleting the proposition that the block is on the table and adding the proposition that it is holding the block. So, these are real actions in the world, but we can also have epistemic actions, actions that reveal information. So, that can happen either privately. So, agent A can tell agent B something, or by broadcasting it to everyone essentially. So, there are 2 kinds of such announcements that you can make, one is private and the other is public. So, an agent may announce that some proposition is true or false, and the agents receiving the information can then eliminate the remaining possible worlds, and this is what we will see now. This kind of reasoning requires models which deal with actions, action models, which is covered in this area called dynamic epistemic logic, but which is beyond the scope of this course here. So, we will just get a rough idea of what is happening. We will also look at this fairly well known puzzle called the muddy children puzzle, and it occurs with variations in many places. And the puzzle is like this, that there are n children who are playing outside, let us say, and some k of them, and this k could be 0 or it could be n, they get their foreheads dirty. So, that is why they are called muddy children. A child can see everybody else's forehead, but cannot observe directly whether he or she himself or herself has mud on their forehead. And for some reason, no child reveals what she sees to anyone. So, if I see you and you have mud on your head, I am not going to tell you that you have mud on your head. So, this is the scenario, and these kids are playing, and some of them, let us say, have mud on their heads. Then comes one of their parents, the father of one of the children comes and announces, which means he tells everyone that at least one of you has mud on your forehead. After having made this announcement, now we want to find out whether children can find out whether they have mud on their forehead essentially. Now, remember that they cannot see themselves, but they can benefit from what they see amongst others and from whatever information is revealed through announcements or through actions essentially. We will assume that the kids are perfectly rational and honest. Whenever they know something and if the question is asked, they will answer that question truthfully. So, what is the question that one will ask now? So, of course, first you go and make the announcement that somebody has mud on their forehead. then he asks, does any one of you know whether you have mud on your forehead essentially, and what will happen in this scenario. So, we do not know how many kids have mud on their forehead, we want to do a general analysis. The assumptions are that the children are perceptive, intelligent, truthful and answer simultaneously. So, if you were to ask how many of you have mud on their foreheads, and if there were 3 of them, all 3 would raise their hands at the same time or step forward at the same time or whatever. So, that is the assumption, and that they are perceptive and intelligent, that they can make all the inferences that we expect an intelligent agent to be able to make. So, remember the puzzles that we had seen, you had to make some inferences there. So, what will the children say? So, what is the scenario? The father came and said someone has mud on their forehead, and then he says, does anyone know, any one of you knows that you have mud on your forehead? Let us say there are k children who have muddy foreheads. It turns out that in the first k minus 1 times he asks the question, the answer will be no for everyone, or in other words they will not say yes. But the kth time he asks the question, all the children with muddy foreheads will simultaneously answer yes. So, let us see how that happens. So, we start with a simple case when there is only one muddy forehead. Since the father truthfully announces that at least one child has a muddy forehead, we and every child know that k is greater than 0. Now, supposing k was actually 1, then there is exactly one child with the muddy forehead, right, because k is 1, and that child can see that no other child has a muddy forehead. So, this announcement that the father made was news to him or to her, as the case may be, and once the announcement is made, he will know that he has mud on his forehead, because nobody else has mud on their forehead. And when the father asks, does anyone you know, then he would immediately raise his hand and say, yes, I know. So, the case when only one child has mud on the forehead is simple, but now the cases become a little bit more involved. So, when we say 2 children, then each of the child can see one child who has mud on their forehead. So, this is a case of 2 muddy foreheads. What happens? So, let A and B have mud on their forehead. So, when the father asks the question for the first time, they both see mud on the other person's forehead and they say no, but they also expect the other person to say yes. Now, A knows that of all the foreheads except his, only B's is muddy. So, A would expect B to say yes. So, if A's forehead was not muddy, B would have seen only clean foreheads. That would have been the case that we considered earlier, and would have known that his forehead was muddy, and B would have answered yes. But since B does not answer yes after the first question, A already knows that he has mud on his forehead. Of course, in a similar fashion B also would know. So, B said no, and this means that A's forehead is also muddy, and with symmetric reason B also realizes that his forehead is muddy. So, the next time the father asks the question, that is the second time, both these children would say yes. And then this kind of argument continues for every k. So, you should go through this in more detail yourself. So, for k is equal to 3, each muddy child sees 2 muddy foreheads. For the first round everyone says no, for the second round everyone says no, but each of those 3 children would be expecting 2 of those others that she can see to have said yes. When they say do not say yes, then she figures out that it is not that k is equal to 2, but that k is equal to 3 and that she is the third person, and so the third time the question is asked, she will say yes. The same argument applies to 4. The first 3 times nobody says yes, but if you are looking at 3 muddy foreheads, you expected those 3 kids to say yes, and since they did not, you know that you are the 4th, and the next time you would say yes. So, it will go on up to any k. So, what is the use of the father's announcement? So, let us take the case when there is more than one child who is muddy. Here each child already knew what the father said. The father said someone has mud on their forehead, and each child would see at least one other person who has mud on the forehead. So, does that announcement really help? Without the announcement, if the father had said, do you know if anyone has mud on their foreheads, then will they be able to answer? Was this announcement useful is the question, and in fact, it was, because without the announcement and the subsequent questions, the children would never be able to conclude that their foreheads were muddy essentially. So, just take the case of the one case here essentially. If the father had not made the announcement and there was only one child with muddy forehead, the child would never know that he has mud on his forehead. When the father announces, if there are 2 children who have muddy foreheads and the father had not announced that you have mud on their foreheads, then there is no reason for anyone to say that I have mud on their foreheads. So, let us see the impact of public announcements here. So, we saw the situation that Kathy was holding card 0, Bob was holding card 1, and Annie was holding card 0, Bob was holding card 1, and Kathy was holding card 2 essentially, and this was the Kripke structure that we saw. And now suddenly Annie announces that she does not hold 1, which is a true statement obviously. In the logics of knowledge, you can only make true statements, and she says that she does not hold 1, which is the case because she is actually holding 0. So, what happens as a result of this announcement, that these 2 possible worlds vanish, because in these worlds she is holding 1 and she has said that she is not holding 1. So, these worlds are not possible anymore. So, out of the 6 worlds, 2 worlds will vanish and we would be left with the remaining 4 worlds. And what can be said in these 4 worlds? After Annie says that she does not hold card 1, Kathy knows that Bob has card 1. So, this is a real world, right, and in that real world Kathy has no connections to any other world. So, Kathy knows everything. Kathy is herself holding 2, Anne has said that she is not holding 1. So, Kathy knows that Anne is holding 0 and therefore, Bob is holding 1. So, Kathy knows everything. In fact, Kathy also knows that what Anne is holding, as we just discussed essentially. But Bob still does not know anything. Bob has not got any new information. Bob was holding 1 and then Anne came and said that I am not holding 1. So, that Bob already knew. So, Bob does not get any new information from the announcement, and this you can see in the fact that Bob cannot distinguish between the world in which Anne is holding 0 or Anne is holding 2 essentially, and the other card being with Kathy essentially. Anne can also still not distinguish between the worlds where Bob is holding 1 or Bob is holding 2 essentially. That is shown by this arrow for Anne from the real world. It is only Kathy who has benefited from that announcement, and that is because Kathy did not know anything about 1. So, now she knows that Anne is not holding the card 1. So, she knows everything else. So, this is a kind of reasoning that we are planning to do, in the sense that we are looking at a set of possible worlds and we want to get more information and eliminate some possible worlds essentially. So, we will look at another example, the example of muddy children that we just saw, and see how that happens with Kripke structures. but we will do that in the next session.